So a train moves along a straight track with an acceleration according to this function over here in meters per second, and its initial velocity of the train is 45 meters per second. To determine the velocity function, it would be relevant now to show the relationship between displacement, velocity, and acceleration. So let's start with the displacement function and then go to the velocity function. And thirdly, let's have a look at acceleration function. And these three functions are related. So when we want to go from the displacement towards velocity and find the velocity, we need to differentiate. Similarly, we can find acceleration from velocity by differentiation also. And if we want to find the velocity from acceleration, then we do the opposite and we do integration. And if we want to find the displacement from velocity, we'll need to also do integration. Okay, so let's see how this applies to this question. We've got a train which moves with acceleration, and the initial velocity of the train is 45 meters per second. Determine the velocity. We have acceleration, we need to find velocity. What do? We do integrate the acceleration. And so velocity is therefore the integral of acceleration, dt. And so we'll just substitute that function for acceleration, which is t over 10 minus 3, and integrate it, dt. And so our velocity function will be t squared over 20 minus 3t plus c. And whenever we do integration, we end up with this value c. But we do know that that train, the initial velocity of the train was 45 meters per second. So we can do this. We can just insert that initially at time is equal to 0. Then, therefore, 0 squared over 20 minus 30 plus c is equal to 45. Well, in other words, c is equal to 45. So our equation for the velocity should be, in that case, t squared over 20 minus 3t plus 45. And the second part of the question says to evaluate the velocity, the integral of 0 to 60, and explain what this value represents. And as I said previously, if we want to integrate velocity function, and say velocity function is here, and we integrate it, we are going to come up with the displacement function. So we're looking at the displacement function with time from 0 to 60. So integrating that, we end up with, square brackets, t cube over 20 times 3 minus 3t squared over 2 plus 45t. So substituting first of all the 60, I'll make that blue, will be 60 cubed over 60, 3 times 20 is 60, 3 times 60 squared over 2 plus 45 times 60, and that is the first, and then to take away with 0, so we'll have a 0, take away 0 plus 0, because all of this will be 0. And we should get 3600, take away 5400, and plus 2700. All this take away 0, and that ends up being 900 meters, because this is, after all, and of course the interpretation of that is that the train travels 900 meters in the first 60 seconds. And that's our answer.